Hey everyone, so in this section we're going to talk about linear inequalities. So this is the first video for that. And if we were in class, I have this fun, well I guess it depends on your definition of fun, but I have this activity that we would have done about spending money at a restaurant. So the idea here is you have a $20 bill and you're feeling very generous, or your friend has a $20 bill and your friend is feeling generous and agrees to pick up the tab for you and your friend. And in class, you would be asked to come up with a couple different meals that you and your friend could have. And if I asked a classroom full of students to do this, everybody would kind of gravitate towards their favorite foods, and they'd all have a different strategy. Some people would say, oh, I want to spend as little as possible. Some people would say, oh, if you're buying, then I want to spend as much as possible. So everybody kind of has their own approach to this. And this is really the idea that's highlighting what a linear inequality is. It's this idea that you could have multiple answers, you just have to kind of stay within the confines of the inequality. So we're going to skip over this page, really, after we've just kind of briefly discussed it. And so just to be clear, what we're going to be working on are linear inequalities in one variable. Those are things that will look like this. So they will have an x somewhere in them, and then they will have some combination of other numbers and whatnot, but we could ultimately all write them like this. And these are the signs that we're going to be looking at. So linear inequalities are a little bit different from equality, right? If we think about looking at this question here, how the previous situation was an inequality, how could we really represent that as an inequality? Well, our meal had to be less than or equal to $20, right? And there were a lot of different possibilities for this. So I'm not looking at the menu right now, but if I wanted to spend as little as possible, that would be a totally acceptable solution if I spent $3.25 on my meal. Or if I spent $19.99 on my meal, that would be totally fine. Even if I spent $20, that would still be fine in that example. So this idea that I have all of these different possibilities, that's what makes an inequality an inequality. And we have this hard limit on kind of what it can be, right? So less than or equal to 20, that's actually very clear. That means that you can have $20 or anywhere between $0 to $20. So with an inequality, how could I represent going over the budgeted amount? What would that look like from an inequality standpoint? Sorry, I keep dragging the screen all over. Well, that would mean that the meal, as I write in highlighter, that would mean that the meal was greater than $20. If you go over the 20, now you've gone over the budgeted amount, and that's a problem. So we have, again, this clear idea of what inequalities mean. But because we have all of these different solutions, we need a new way to kind of represent our solutions. So that's where we're going to start in this video. So going to the next page. We've talked about this in the past. This was actually, I think, something in chapter 1. We talked about number line notation and interval notation. This is really a quick reference guide for you. All this stuff up here. And I'll refer to it in a few minutes. So the other thing I want to point out is what set notation looks like. So why don't we just get started with this example, and then I can kind of use all the stuff in these tables. So what I want to do is I want to describe the solution set to x is greater than or equal to 3. So there are 3 different ways that you can represent solutions of inequalities. The first one is on a number line. And so you're going to create a number line. It's exactly like what it sounds. And you need to mark that number line with whatever number, of course, we're talking about. So here's my number line with a 3. So now here's where this table is going to come in handy. So my question is 3 included or not included in my solution set, just looking at this? Well, it has to be greater than or equal to 3, so that means that 3 is included. So this is where this comes in handy. If the number is included, you can either use a square bracket or a solid dot. So you can either do, let's see, I'll do this in the red color, a square bracket, or you can do a solid dot. Either one of those is fine. So that represents whether or not 3 is included. And then the other part of this is you have to actually shade your number line to show the solution set. So where are my x's, where are my answers bigger than 3? Over here, on the left side, or on the right side? It would be on the right side. This side over here, this is all the numbers that are greater than or equal to 3. So that would be what your solution looks like on a number line. Now, after you have the number line, move this down a little bit. After you have the number line, then you can work on the interval notation. So the interval notation, I think of it like reading a book. You read it from left to right, and you're talking about where your solution set starts and where it ends. So in this case, as I'm going along my number line, I have nothing shaded, nothing shaded, nothing shaded, and then it's like donk. Okay, there we are. That's where my solution starts, right? So I'm starting at 3. And so with interval notation, so that's what I've included up here. So when the number is included in the interval, you use a square bracket. So you'll notice that this notation is actually very similar to what you've got for the number line. So I've kind of have both of those up there just so you can kind of review them. So I'm starting at 3, and my 3 will get a square bracket because it's included. Now, the next part of this to know is kind of what these directions on the number line mean. This direction this way, this is the positive infinity direction. This direction this way, this is the negative infinity direction. So this will matter. So on my number line, I've started at 3 and I'm going just all the way out to here. And when that happens, that means you're going in the infinity direction. So I'm going to just write infinity. And then what do I put on the infinity? So you use a round bracket also for always for positive or negative infinity. So this is a very handy little chart up here. So that's the interval notation. All right, so now for the set notation. So the set notation always has the form of this. So you're going to set up these pieces here. That part always gets set up, and then what you fill in here is whatever your answer is. So in this case, I just plug in the x is greater than or equal to 3. Okay, so that's how you do an inequality in one case. Now I want to show you another case. So now I want to show you just what to do with a 3-part inequality, just so we get all of this out there in the open. So here's what a 3-part inequality would look like. Let's say I've got something like this. So negative 3 is less than x, which is less than or equal to 5. So the first thing to know about this is how to actually read this, because a lot of times when people read this, they just see all these signs and then they start reading it, and people will tell me, oh, it's negative 3 is less than x is less than or equal to negative 5. And it's like, what does that actually mean? So what is the easiest way to explain what this actually means? This is saying x is between negative 3 and 5. That is how math describes this sentence. And you know by looking at this that negative 3 is not included, but 5 is. Okay, so let me show you how to do the number line with this. So you've got your number line. My number line is not to scale, but I've got these pieces. So if I know that this stands for x is between negative 3 and 5, I totally know where to shade this already, right? It's everything right here. And now it's just a matter of how do I mark the rest of this. So 3, will it get a, let's use dots this time. Will this get a open dot or a closed dot? Negative 3 is not included, so it gets an open dot. And then will 5 get an open dot or a closed dot? Well, 5 is definitely included because it's less than or equal to, so this gets a dot like this. Okay, so there's the first part. So now let's talk about the interval notation. So for the interval notation, as I go along here, so I'm starting at negative 3. So does negative 3 get a square or round bracket? Maybe you want to pause the video just to look at that list. So it should get a round bracket, and then what about 5? So this goes all the way up to 5, right? And does 5 get a square or round bracket? It will get a square bracket. So you might want to keep referencing that table as just kind of a little bit of a cheat sheet while you're getting used to this. Once you get it down, it's okay, but it usually takes people a little while to do this. Obviously, I can speak through this because I talk about this all the time, it feels like. So I know this pretty well. So I would highly recommend just have that page open with the little chart for yourself while you're getting used to this. And then for the set notations, remember I told you that you just want to set this thing up, and then it's just dropping the answer in there like so. So nothing to it with set notation. All right, so now you've got kind of the idea behind this. So now what I want to do is I just want to give you 2 examples to do on your own. So why don't you do x is less than 4, and you can also do, how about 0 is less than or equal to x, which is less than or equal to 7. So I want you to represent those on a number line, interval notation, and or set notation, and then hit play when you're ready. Okay, so starting with A here. So here's my number line. Here's 4. So which side of the number line am I going to shade, the left or the right? Where are my x's less than 4? It's everything over here. Now, 4 is not included, so you're going to put either a round bracket or an open dot, either or, it doesn't matter, right there. Now for the interval notation. So remember, this direction is the negative infinity direction. So that's actually where we're starting now as I go from left to right. So I start here at negative infinity, and I go to 4, and that's actually it. That's my whole interval notation. And then my set notation, I'm cramming everything here. You'll see why in a second. This is x is going to be x such that x is less than 4. Okay, so there's that one. So now let's do the other one. So here's my number line. Start at 0 and 7. And so in this case, both of these numbers are included. So I'm going to use a square bracket, or I can use a closed dot, whichever one you want. So I'll just note you could also do a closed dot. Totally doesn't matter to me. Different homework systems do different things, so I just tell everybody all the options. Okay, and then for my interval notation, so now my interval notation is starting at 0. 0 is included, so it gets a square bracket. Goes up to 7, gets a square bracket. And then my set notation, this is always the really simple one once you get the idea. Okay, so that's really what I want to talk about in this video. So if you'd like to see 2 more examples, I've got those for you. And if you're good, then you can just stop here. But for those of you who maybe want to see more examples and just try that one more time, I will give you just 2 more examples, and you can hit play when you're ready again. So I've got x is greater than or equal to 2. And then I've got negative 3 is less than x, which is less than 2. So go ahead and try these, hit play when you're ready. Okay, so, as I lose the whole page, sorry. Sometimes OneNote is a little finicky. Okay, so my number line, so I start here at negative 2. And so here's the greater than direction, and you'll either get a square bracket or a closed dot. Just FYI, I tend to use square brackets. It's just a force of habit, but if you use a closed dot, it's still the same thing. And then I'm going to start here at negative 2 with my interval notation, and I go in the, that's a terrible looking infinity direction. Infinity always, always, always gets the round. You have to repeat that to yourself. Infinity never gets a square bracket. And then my set notation will look like this. Okay, and now for my number line for D. So here's negative 3, here's 2. So I need to shade everything in between. I use a round bracket for each, or an open dot. Maybe I'll just note that, open dot. Open dots, doesn't matter. So my interval notation will start at negative 3 and go to 2, and neither of those numbers are included. And then I've got x such that negative 3 is less than x is less than 2. Okay, so we're going to do a lot more with this. So if you're still feeling a little shaky, don't worry, you're totally going to understand this by the end of this. But this seems like a good place to stop this video, so I'll pause here and I'll see you guys in the next one.